Assalamualaikum warahmatullahi wabarakatuh. We are from student AS120 is going to present to you about the gravimetric analysis, which is determination of CL in aqueous solution.
Hi everyone, today we will discuss the gravimetric analysis for determining chloride ion in aqueous solution. Determining the concentration of chloride ion in aqueous solution is a fundamental analytical procedure in chemistry. This process involves various methods such as saturation, precipitation, and ion selective electrode measurement. These analytical techniques are pursued in various fields, including environmental monitoring, pharmaceutical quality control, and industrial process. Accurate assessment of chloride level is essential as it impacts chemical reaction and material properties. Next, let's go through for the next slide on the purpose and method of precipitation, which is one of the key techniques in gravimetric analysis. The purpose of the precipitation method is to separate and quantify a specific analyte in a solution. In this process, we convert the analyte into an insoluble precipitate. By doing this, we can isolate and measure the analyte precisely. This method is particularly useful in analytical chemistry for determining the concentration of ion or compound within a mixture. As you can see from the diagram, the process typically involves adding a precipitating reagent to the analyte solution, forming an insoluble compound that can be filtered dry and wet.
Before we dive into the specific reaction, let's discuss the theory behind the precipitation method. In this method, the analyte is converted to a spiraling soluble precipitate. This precipitate is then filtered and washed free from impurities. After that, it is transformed into a product of stable and no composition through a suitable heat treatment. Precipitation is also a technique used to measure analyte by turning it into an insoluble solid. This allows for the precise quantification of the analyte is given simple. So here I'm going to give you an overview of the chemical reaction involved in precipitation, focusing on three main types: metal hydroxide precipitation, carbonate precipitation, and sulfide precipitation. This process commonly used in water treatment to remove various contaminants. First, let's discuss metal hydroxide precipitation. This method is partially useful for removing heavy metals like iron, ferrum, manganese, and plumber from water. This chemical reaction involves metal cation in solution reacting with hydroxide ions to form insoluble metal hydroxide. For example, iron ferrum precipitation. This you can see the equation: ferrum 2 plus with 2 OH minus. Then you can get the ferrum hydroxide. Next, we have carbonate precipitation, which is often used to remove calcium and magnesium ions that contribute to water hardness. In this process, can iron react with carbonate ions or bicarbonate ions to form insoluble carbonate? For example, Ca2 plus with carbonate ion, you can get the calcium carbonate. Finally, let's look at sulfide precipitation, which is effective for removing heavy metals such as cadmium, zinc, and copper. In this reaction, can iron combine with sulfide to form insoluble metal sulfide? For example, cadmium sulfide 2 plus with sulfide 2 minus, you can get cadmium sulfide.
As you can see, this is a sample precipitation method. Step 1. Two solutions of soluble substance are mixed together in one beaker. Step 2. The precipitate and filtered off. Step 3. The filtered precipitate is washed several times with deionized pure water. Step 4. The insoluble salt is carefully scraped off the filter paper into a dish and dried in an oven. The objective of this experiment is to accurately quantify chloride ions in aqueous solution using the precipitation method. So, I want to talk about the apparatus and chemical involved in this experiment. The apparatus required includes analytical balance, beaker, and plus filter paper for filtration and precipitate. The next one is funnel, Bunsen burner or hot plate, wash bottle, and the last one is desiccator. The chemical involved are the first one sodium chloride. NaCl, the sample to be analyzed. The second one is silver nitrate, AgNO3, the precipitating reagent that reacts with Cl negative ions to form a HCl precipitate. Number 3, distilled water, the solvent for dissolving NaCl and preparing solution. Number 4 is nitric acid, used if need to adjust the pH or remove impurities. The last one is filtering aid.
These are the procedure for the experiment. First, accurately measure the sodium chloride sample and dissolve the sample in distilled water. Next, add a sufficient amount of silver nitrate, the precipitating reagent, to the sodium chloride solution. This will cause the silver chloride precipitate to form. Next, filter the resulting silver chloride precipitate using filter paper to separate it from the solution. And then, wash the precipitate with distilled water to remove any soluble impurities. And after that, dry the washed precipitate to eliminate residual moisture and weigh the dried precipitate along with the filter paper. And we can determine the weight of the precipitate containing chloride ions by subtracting the weight of the filter paper. These are the results for the experiment. Silver nitrate is titrated against chloride ions to produce a white precipitate. When all chloride ions in a given sample has all been converted to silver chloride, additional silver nitrate reacts with yellow potassium chromate to produce reddish brown precipitate. And at the end point, when it's reached, the reddish brown color remains stable and does not disappear when stirring.
Okay, let's continue with the advantage of this method. The first one is high accuracy and precision. The gravimetric analysis provides highly accurate and precise results when properly conducted. This is because the method relies on the measurements of the mass, which can be done with a great precision. The next one is simplicity. The technique is straightforward and does not require complex instrumentation. The simplicity makes it accessible and easy to implement in various settings. And the last one is cost effectiveness. The reagent and equipment required for gravimetric analysis are generally inexpensive compared to another analytical techniques. This makes it a cost-effective option for many laboratories. Okay, while gravimetric analysis has many advantages, it also has some disadvantages that need to be considered. The first one is time consuming. The process involves several steps such as precipitation, filtration, washing, drying and weighing. These steps can be time consuming and require careful attention to detail. The second one is potential for contamination. During the multiple handling step, there is a risk of contamination, which can affect the accuracy of the result. The proper technique and clean environments are essential to minimize the risk. The third one is interference from other ions. If other ions in the solution from precipitate with the chosen reagent, they can interfere with the determination of chloride. This requires careful selection of reagent and conditions. And the last one is drying and handling issue, which is it will ensuring that the precipitate is completely dry and free from any absorbed moisture or other volatiles can be challenging. Accurate weighing depends on the complete removal of this substance. In conclusion, let's summarize the effectiveness and application of this method. The determination of chloride ions in aqueous solutions using the precipitation method is a reliable and effective technique. By reacting chloride ion with a silver nitrate to form silver chloride precipitate, followed by filtration, washing and weighing, accurate quantitative analysis can be achieved. This method is widely used due to its simplicity, cost effectiveness, and ability to provide precise results. And the last one, it is valuable in various scientific and industrial applications, where chloride ion concentration need to be determined with high accuracy. Thank you for your attention. That's all.